We're going to continue on now talking about formula mass. It's extremely important that you understand how to calculate the formula mass. So we're going to spend a great portion of this time talking about how to do that. So what is a formula mass? A formula mass is the sum of the average atomic masses of all the atoms in a substance as represented by the substance's molecular formula. Formula masses are usually calculated based on the molecular formula. The spatial formula is not meaningfully different in terms of mass, so it's not really important in this calculation. And the empiric formula is not useful in this situation because it's the simplest representation and it doesn't really represent what you're actually dealing with. So you generally use the formula mass. I might actually say you always use the molecular formula in order to calculate the formula mass. So let's look at an example of the calculation of a formula mass. This is a compound called chloroform. Now chloroform, here is the molecular formula for chloroform. Here is the spatial formula in a ball and stick conformation, and you can see the green chlorines here, a central chloride or carbon, and then a hydrogen atom here. So how does one go about calculating the formula mass? First of all, you list all of the elements that are contained, carbon, hydrogen, and chlorine, and the number of each. There's, according to this formula, there's one carbon, one hydrogen, and 3 chlorines. And here you have 3. Then you go to your periodic table, which is either in your book or the one I gave you in class, and you look at the average atomic mass, which is given on the periodic table. For carbon, it's 12.01. For hydrogen, it's 1.008. And for chlorine, it's 35.45. Remember, these are average, weighted averages of all the isotopes that exist for each of these. That's where these numbers come from and why they have decimals. And then you multiply the quantity by the mass and you come up with the weight contribution of each of these atoms or elements. So 1 times 12.01 is 12.01, 1 times 1.008 is 1.008, and then 35.45 times 3 is 106.35. You add these up and the molecular or formula mass for chloroform is 119.37 AMU. That means that one molecule of chloroform, CHCl3, has an average atomic mass of 119.37 atomic mass units. Let's look at another example. Here is a molecule of aspirin. The molecular formula of aspirin is C9H8O4. Here's a stick model of the aspirin. Black are the carbon atoms, red are the oxygen atoms, and white are the hydrogen atoms. So you write down again each element, C, H, and O. C, H, and O. O has 4 oxygens. H, there's 8 hydrogens. And C, there's 9 carbons. From the periodic table, you know that 12.01 is the average atomic mass for carbon. 1.008 is the average atomic mass for hydrogen. And 16 is the average atomic mass for oxygen. You take 9 times 12.01 is 108.09. 8 times 1.008 and it's 8.064 for the mass of hydrogen in the molecule. And then 4 times 16 is the mass of oxygen in the molecule. You add it up, and the average atomic mass for aspirin C9H8O4 is 180.15 AMU. So at this point, I want you to practice, and then we'll show you. This is the molecular formula for ibuprofen or Motrin. I want you to stop the tape at this point, and on a piece of paper, I want you to write this formula down, and then write a box just like I have, because that's what I'm going to show you in just a minute, and see if you can calculate the formula mass for ibuprofen based on what we just did. This is the box you should have drawn. If you didn't stop your tape, then you didn't get as much benefit as if you would have stopped it and drawn the box the way I asked you. So when we do the next one, see if you can do that. Again, you see here that there are three elements, C, H, and O, and you write those down first. Then you look at your subscripts, the 13, the 18, and the 2. Those are called subscripts. And you see that there are 13 carbons, which is the quantity, 18 hydrogens, which is the quantities of the number of hydrogen atoms, and 2 oxygen atoms. The average atomic mass for carbon is 12.01. The average atomic mass for hydrogen is 1.008. The average atomic mass for oxygen is 16. 2 times 16 is 32. 18 times 1.008 is 18.114. And 12.01 times 13 is 156.13. If you do the math, you get 206.27. So the average molecular mass of ibuprofen is 216.27 AMU. And that's also called the formula mass for ibuprofen. Here's another example, and I chose this one because it didn't have carbon, hydrogen, and oxygen in it. This is table salt, and table salt is made up of chlorine ions and sodium ions. Its molecular formula is NaCl. In order to calculate the formula mass for this, you write the elements down, Na for sodium and Cl for chlorine. There's one each. The average atomic mass for sodium is 22.99. The average atomic mass for chlorine is 35.45. 1 times 22.99 is 22.99. 1 times 35.45 is 35.45. You add those two together and you get 58.44. And so the formula mass for sodium chloride or table salt is 58.44 AMU. Now the arrangement of the sodium chloride is in a fairly tight lattice structure, which is shown in the ball and stick formula. But that really doesn't impact how you calculate the formula mass, because it's the mass of one molecule of sodium chloride. So given that, I'm going to throw you one that's a little bit more difficult, and that's aluminum sulfate, Al2SO4 3. Now I'll give you a hint before you turn the tape off, in that if you have a 3 outside of parentheses like this, it means everything inside the parentheses is multiplied by 3. So that you have 3 sulfurs and 3 times 4 or 12 oxygens. Now stop the tape at this point, make your box, and see if you can calculate the formula mass or molecular formula for aluminum sulfate. Here is this box. You have aluminum, sulfur, and oxygen. Aluminum has a subscript of 2, so you have 2 aluminums. I told you that if you have this 3 outside the parentheses, it means you multiply everything inside by 3. So you have 3 sulfurs and 3 times 4 or 12 oxygens. You look in the periodic table and you find that there are the atomic mass for aluminum is 26.98. The atomic mass for sulfur is 32.06, and the atomic mass for oxygen is 16. 2 times 26.98 is 53.96. 3 times 32.06 is 96.18. And 12 times 16 is 192. You add those three together, you get 342.14 AMU for the formula mass or molecular mass of aluminum sulfate. And then you can see the stick structure here shows how the aluminum sulfate is put together. It might be a little confusing to you, so I wouldn't spend a whole lot of time looking at it. But that's how the aluminum sulfate is put together. And that's actually more than one aluminum sulfate molecule in that picture.